Welcome again. Today we are going to look at what we call the internal constraints. We are going to look at the internal constraints. Remember that we are still looking at what we call the thermodynamic system. In our previous episodes, we've looked at what a closed system is. So in this closed system, we want to look at what we call the internal constraint. Now, we still remember the system which we had previously, which had subsystems 1 and 2. Let's try to remember the subsystems. So if we have these subsystems 1 and 2 of this system, of this thermodynamic system, trying to ensure that it is fully closed, this is 1 and this is 2. Suppose that the partition between 1 and 2 is fixed, rigid, and adiabatic. Then this partition is called an internal constraint of the composite system. So if this is really fixed, rigid, and adiabatic in such a way that there are no particles that are going to be exchanged between the subsystems, then this partition here will be called an internal constraint. It prevents the exchange of heat between subsystems 1 and subsystem 2. So there will be no heat exchange. No heat exchange. That's the first thing between subsystems 1 and 2. So between subsystem 1 and 2, there will be no heat exchange. This heat exchange will not be there. And then also, the exchange of volume will not be there. No volume exchange. So volume 1 and volume 2 will remain constant because there is an internal constraint. And then there will also be no exchange of particles. No particle exchange. So the particles will remain the same. Number of particles in subsystem 1 will not exist in subsystem 2. There will be no exchange because there is an internal constraint between subsystem 1 and subsystem 2. That's the first case. Now in the second case, what if this partition between subsystem 1 and subsystem 2 looks like this? So this time I'm drawing a bigger subsystem 1. Let me undo something here. Okay. So this time I want to use a partition that is quite different from the previous. Something like that. Then we have subsystem 1 and subsystem 2. Then this outer revealed adiabatic wall. So this is 1 and this is 2. So still these having the same particles N1 and N2, V1 and V2 as the volume, and U1 and U2 as the internal energy. So in this case, this partition is still an internal constraint. But however, the way it prevents the motion of these items also differ. Now, we've said that the partition is still an internal constraint if it prevents the exchange of volume of subsystems and the exchange of particles between the subsystems. So if volume 1 cannot be allowed to interchange with volume 2, and also number of particles in subsystem 1 cannot be allowed to interchange with number of particles in subsystem 2, this partition here is still an internal constraint. Now, what if the diabatic wall is surrounding, but this partition here is diathermic? In other words, it allows the movement of V1 and V2 and such that such that V1 in this second case if it allows the volume V1 to change with V2, for example, if there is much pressure in subsystem 2, then the volume of subsystem 1 changes, adjusts. So although the fact that V1 plus V2 is still constant because we are still looking at a closed system, we said for a closed system V1 and V2 plus V2 should remain constant. We are looking at, for example, we are looking at a situation whereby subsystem 1 has a volume of, say, subsystem 1 has a volume of like 20 cubic meters, that is V1, and say V2 is 40 cubic meters. sorry about this, not cubic centimeters. Cubic meters. Then, if this system is in such a way that the two can be allowed to share, because when you add this V1 plus V2, you get 60 cubic meters. Now, if this system allows such that V1 becomes 30 cubic meters and V2 becomes also 30 cubic meters, then it implies that one system, one subsystem can do work on the other. This is what it implies. In this case, there is an internal constraint, yes, but one system, one of the systems, of the subsystems, of the subsystems can do work on the other. Can do work on the other. Thank you very much for watching, and God bless you. Have a nice time.